I would probably guess the u is probably going to be the denominator, and I think that's going to work out because then du looks like the numerator. You see how that worked out? Okay, so this would be 1 over u, and then instead of all of this, I can put in du. You're okay there? In place of 2x dx is equal to du. So I just replace 2x dx with du. And all of this is over x squared plus 3. So that's 1 over u.
I just did an extra step underneath it.
Okay. Now this came up just a minute ago, and I think it's good for you guys to connect your understanding here and why we have one of the rules we need to have. You could, I wouldn't do it this way, but you could rewrite this with exponent rules like this. But notice if you just try to undo power rule here, if you raise the power by 1, you get that. But then you're supposed to divide by the power, and you can't divide by 0, right? So when you have an exponent of -1 like this, you can't think of this as undoing power rule. We have a different way of dealing with it. What's the thing that we can take the derivative of to get something that looks like this?
Natural log.
Right. And that's the whole purpose of natural log. It's not that we just like to use it and we don't really need it. We need it for this situation. It does not fit power rule. So natural log, absolute value of u plus c, and then plug your u back in.
You're integrating to get natural log?
Correct.
Or are you taking the derivative?
Integrating. If you take the derivative of natural log of x, you get 1 over x.
Yeah.
If you integrate 1 over x, you get natural log of absolute value of x. So you got to know both directions.